Hi, my name is Helge Maus from pixeltrain. I'm a 3D and visual effects trainer, and therefore I train, beside of Houdini, also Cinema 4D and Maya. In this little tutorial series, Procedural in Motion, I want to talk about the process of tool building inside of Houdini for making your work, building abstracts, motion design or commercial work much easier. Houdini's natural procedural approach helps you to build tools which start simple and then are added more and more with functionality. And if the client changes mind while you are working, you can add your stuff if you need, or you can reuse your tools also in other projects. So it's much more flexible instead of throwing away all your solutions if you have to make a change. This tutorial series is really basic. It's meant for people who have a basic knowledge of Houdini but really are starters, and I want to show you the processes which you need inside of Houdini to build your own tools. For this first project, I decided I want to do a rasterizer, and this here is the final image we want to do. And it's inspired by an image here from an artist, Rich Noseworthy, which was used in many Cinema 4D tutorials to show how MoGraph works for building such a surface. And I found that this is a good starting point for doing this stuff here in Houdini. So let us start. I switch over to the scene view, also here the scene view. And our starting point will be a grid. So we can add an empty geo, dive inside, and get rid of the file node. We don't need this at this point. Instead of this, we need a grid. And the grid is like a plane in other 3D applications. You can change now the size and the columns and rows of the plane here under the attributes, but you also can switch here to the handle tool, which gives you here this option bar and also handles here in the viewport. If you hold down the Shift key, you can work symmetrically. That's really nice for our plane here. And after changing the size, I try now some values here to get a nice division here of my plane. Maybe one or two more, something like that. Okay. In the next step, I want to have a more organic shape. For this, I use a sculpt node. If you hold down the Shift key while pressing Enter, you get directly the display flag here on the new node, you get a connection, and so it's much faster instead of adding every node by hand. Okay, the sculpt node is now selected. I can go back to my handle tool, and if you take a close look to my mouse cursor, you see we have this little radius, which we can change by holding down the Shift key. Also, you have here on the left mouse button a positive value, and on the middle mouse button a negative value, for changing here what this sculpting brush does. The same thing here under the sculpting node. Here's the operation. We can change the axis, for example, to Y, so that we only change here the directions into the Y axis. And also here you have the left and the right mouse button to change here the strength of them. If you want, you can work with symmetry, the brush you can change, and also the stroke type. But in our case, we only want to shape here a little hill into the middle, and if you want to lower some regions, hold down the middle mouse button to do this here. This is our prototype, so keep that in mind. Later we can change the object we want to rasterize, so this here is only for playing with our tool. In the next step, we want to change now these square shapes into triangles, and for this I use the divide node. The divide node does exactly what we want. We have now our triangles here, but if we take a closer look here to the original, you see we have gaps between these triangles. And to making these gaps, we want to scale in every polygon, or in Houdini they are named primitives, and for this we have to disconnect them from their neighbors. For this approach, we can use a facet node. A facet node does many things. You can change the normals and so on, but in our case, we want to use to split this surface here. And if you want to look a little bit behind the curtain of Houdini, hold down the middle mouse button and click here on this node. And so you see exactly what you have at this point. We have 154 primitives or polygons, but only 96 points. And you see here we have vertices. This is a little bit confusing if you come from other 3D applications. Vertices are the borders of every primitive or polygon, but some of them are shared because you have here a contiguous mesh, and that's the reason why we only have 96 points. If we split now these polygons, the point amount will increase. So to split, we can use the option here, unique points. And you see that also the font shading here changes because every polygon is now separated from the neighbors. And if we make our middle mouse button click again, you see exactly what we are talking about. Okay, another nice option is here, make planar, so we don't have curved surfaces in any kind. This is also very useful for this point. Okay, now we have our faceted surface. The next step would be that we want to scale every polygon in here so that we get a little gap. For doing that, we can use a primitive node. A primitive node, like the name says, works on a primitive base. You also have a point node, for example, but the primitive node, like I've said, works on a primitive base, and you can change the attributes of a primitive, or you can add attributes. One example would be, if you want to add a primitive like a color to a primitive, you can switch here to attributes, and here you see the option keep color, and if you make your middle mouse button click here, you see we only have some point attributes but no color in the moment. If you want, you can add a color here, remove this expression, which is here by right mouse button click, delete channel, and then we can change here the color, for example, to red. And now every polygon or primitive is red, and if you hold down the middle mouse button, you see now on every primitive we have an attribute with the name CD for color, and that's the job of the primitive node. In our case, we keep the color, we remove this, and instead we go to the transform. We can transform now every primitive, so do the transformations. And before we do something, you see here we have under pivot also an expression. To see this, you can click here on the word pivot, and you see the expression says that there are local variables, which means the center of every primitive is the pivot of this transformation. So you don't have to think about where's the center. Houdini does the job for you. So we can go over the scale, hold down the middle mouse button, and then we use the ladder to make these polygons a little bit smaller. And that's the look we are after. Now we need a little bit of thickness for these pieces, and for this we use the poly extrude tool. With the poly extrude, we can select our handle tool, and you see here is a little helper. Also we have here a HUD where we can change the distance also here, or you can go directly here in the node and change the distance here. Okay, I bring these surface a little bit down. I go downwards. You will see in a minute why downwards, because it's later easier to add stuff on the surface here. So that's the only reason at this point, and I can change here the value so that it's 0.07. That's good. Also, we need some back faces for this area, so we tick here output back, and if we look here now, we have now something with thickness. In the next step, we want to add a little bit of a bevel so that the rendering is nicer, and for this we can use the poly bevel node. If you add this now, we change some options. The first thing is the fillet. I want to have a round fillet. You can change here the divisions, for example, to 2 or 3 with the fillet, and then we can change here the offset. And if we do that, and we take an extremely close look, here we are. You see now we get a nice fillet. But beveling is really dangerous because if you drag it too far, you get these ugly distortions. And to remove them or to prevent them, you can use here the use common limit. So it's a really nice option here in the bevel tool so that you don't overdo it. I think that's nice until this point. And now we can talk about the output. At the end of a chain like this, I normally do a null object. This null object here is only connected here, and I name it out Rasterize. And if you press the C key, you get here a little color palette, and I color this here black, so that I later can see where's the end of my chain. And you see, every step we've done in Houdini is now encapsulated in a node, and we can go through these nodes and change some of the options. For example, if we now want to change the scaling for the gaps, we can go here to the primitive node and change the scale amount here. And the rest of the change still works, and that's really the power of working in such a procedural way. Until now, we went a really straight way to a solution we want to have. But what if you want to add now more stuff to your object? For this, you only have to search for a point where we want to add something. And for this, I change the display flag. I want to add something on the surfaces of these primitives. Something like, for example, here these little balls or something like that. For this, we need the primitives themselves. And if we go through the chain, we find here after the facet node that we have now the separate primitives at this point. So I take this whole tree and move it aside. I want to find now the midpoints of every of these faceted polygons. And there are different ways of doing it. You can do it in VFX, which is the programming language inside of Houdini, but I found a really visual way of doing it. And we use for this the primitive node as well. So we take a primitive node. I remove it here, add it here, and take the display flag. And then I go in here and scale every of these polygons until they are 0. Okay, so 0, the scaling out. Now it seems that nothing is there anymore, but if you hold down your middle mouse key, you see everything is still there. And if you go in here and make the points visible, there are still points. But these points here are no separate points. This is always a cluster of points because every primitive head is points and they are scaled together to one point. And to remove all the unused points, I want to merge them or fuse them. And for this, I use the fuse node. Inside the fuse node, we have an option here. Normally it fuses everything which is inside this threshold distance here. We can say keep the consolidated points. So we still keep one point in the middle, the point which all the other points are melted to. And so if we compare this, here we have 462 points. After the fuse node now we have 308 points. So everything is fused together at this point. And now we can use these points for cloning stuff onto them. Okay. We clone little spheres. Take a sphere node. I make a little polygon mesh. We can make them visible and we can template here the fuse so that we see where the points are. And then we can change the uniform scale here a little bit so that they are smaller now. And then we can use the copy to points node, which is like a cloner. Here on this first port, you can read this here in the status area. You see these are the primitives to copy. This is our spheres. And this second input here are the target points where we want to copy to. And if we select this now, you see we have a sphere on every point now. And then we can merge these two tree parts together, or these two branches. If we add now a merge, we can add now the result of this branch and the result of this branch. And the output now is the output of the merge here. And if we tick this now, you see exactly the result we are after. And if you want, you can still change here, for example, the size of the sphere. But I think for this example, something like that here is exactly what we want. So that finishes the building of our first prototype tool. Now comes the point I said we can use this prototype for rasterizing other objects as well. If we go here and we bring here the grid with the sculpt a little bit to the side, the whole rasterizing process begins here with the divide node. Let us take a platonic, for example, and we change the platonic here to, for example, a soccer ball. And if I select this here, we can make it a little bit bigger. Okay. And if we now change the input of our rasterizing process, I take this line here and drag it over to the platonic. And then we set the display flag here to the output. You see the rasterizer still works, and you can still work with all the parameters we had here inside. That's the real power behind this process. And now we can think about how to encapsulate this tree here so that we can reuse it later more easily. For this, I select now all the nodes which are part of the rasterizing process, and then I click here on this little icon, or you can also use here the keyboard shortcut Shift-C. This makes a subnet of all these nodes, and you get this little subnet node here instead of your whole tree. And we can name this Rasterizer. This subnet here encapsulates everything you have done so far. If you want to change something, you can make a double click, go inside, and you see the only difference instead of before is that you have now these little inputs here, which help you to input more than one data source. But you can change your asset while you're inside this network. But if you want to reuse now this rasterizer in many more projects, it would be much more suitable if you have the most important parameters, or the parameters you normally want to change, not inside of this subnetwork, but on this node itself. You build your own node now. And for this, we can change the user interface of this node. For this, you select the node and you click here on this little cogwheel and go to Edit Parameter Interface. In this dialog, you have 3 columns. Here in the middle, you have the existing parameters on this node. This is exactly the thing you have here. On the left side are pools where you can get new parameters. One by type, then you have render properties. You also have node properties, and you can pick nodes from a network which you have somewhere in your Houdini file. But the most easiest way of adding stuff, from my perspective, is later to take it directly from the subnetwork. But first, we want to have a subfolder here. For this, I switch here to by type. And if you look through here, you find here a folder which you can add here. And if you selected the folder here, you have the parameters here on the 3rd column. Be careful, we have 2 things, one name and one label. Label is human readable. So here you can write everything you want with spaces and all this stuff. But the name here is important if you want to program later, and so you are not allowed to use special characters. So make this here a little bit more like in a programming language. We start here with the name Rasterizer under the label. Okay. And if you want to test how it looks, click here onto Apply. And you see here on the right side, this here makes this new section here for the Rasterizer. And now we go into the subnet. You don't have to close this interface. And we go through our network and find the nodes, or better, the nodes and their parameters you want to change later. until this point here, nothing happened. We faceted our network. But then we had this primitive node, and in this primitive node, we changed the scale for making these gaps here in our scene. And this is something I want to change later. So I take the scale and drag it over under my folder. And now you see, here's the name from the programming perspective, and here's the name which you see. And here you can change, for example, the scale to scale pieces. So that's a little bit more obvious what this thing here does. Also, you can change here the range which you allow for this parameter, -1 to +1. If you want, you can say, no, I don't want that it goes negative, for example. And under channels here, you also can add defaults here. So if you say you have a new file here and you use the rasterizer, you can tell the system, okay, I want to use a value of 0.75 for this field as a default. And if you press apply again, you see your object changes because now the defaults kick in, and then you can change them from this point on. The next thing we want to change, this was the primitive, is the extrusion. So I go here to the extrude node. Here we use the distance. We name this distance thickness of the pieces, for example, or thickness, pieces sounds good. We are negative here at this point. Maybe you want to change it. We can leave this alone for the moment. If you want, you also can add an insert for the pieces. Then we go a little bit deeper to the bevel. Here we have the offset of the bevel. And we can try to get this here. Okay, this is offset. And here you see this here is not exactly what we are after. It's the offset here, this field, but not this field here. So if you want to get rid of something, you can delete this. And now we can drag this value over and write offset value, and we can press apply and test this really fast. You see it's green now. That means in the background there is an expression going on. Let us test this. Make this really big here so that we can see what's going on, and then we change here the value, and you see, yeah, it's working like expected. That's good. Okay, so we go back here. If you want, you can change here the range because we have really, really small values. Maybe it's absolutely enough to go to 0.5. Let us test this again. And yeah, you see now it's a little bit easier to work with the slider with this value here. Let us finish this. Then we have here the right side of our tree. This here is only for getting the points, nothing behind this here. Maybe we want to change the sphere size here. For this, I take another folder and we tell here this is for the spheres. And then we can take the sphere here and take the uniform scale of this and maybe the frequency. That's it. Now we can press accept, go out, and now we have all the parameters together for our rasterizer. So if you want to change here the scale of the spheres, here we can later also change the range. We have the offset value here for the bevel, we have the insert here, and we have a thickness here. So everything is here now together. And yeah, that finishes this first part of the tutorial. We have now a rasterizer tool which we can use in other projects as well. And we see each other in the next lesson, if you like, when we start with texturing and making this renderable.